get stuck in if you are.
Yeah, I think good to go. I just started recording.
Perfect. Great. So I'll go back to our previous slide. So firstly, just a quick thanks to Shane and to Hoya and Michael behind the scenes. I don't think I've met Michael just yet, but for organizing this and yeah, putting it all together. So I really appreciate that. And that was on behalf of CSC SOC. So they've done a great job. And I hope to give you an interesting talk today. So throughout, please feel free to ask questions either in the chat or turn on your microphone. That's totally fine. Even if it's something that seems really simple, I think for most people here, a lot of the stuff is going to be new. So feel free to ask, really don't hold back at all. So I'm Ryan, I'm a fifth year maths student, currently doing a thesis on quantum computing. And next year I'll be starting as a software engineer at Atlassian. So a little bit about me. My first exposure to programming at all was actually using R. That was while I was interning at Commonwealth Bank in their data science team there. And that was, yeah, as I said, before I did C, before I did Python. So I was kind of in a lucky position to be able to do that. But yeah, for that reason, it was my first exposure to programming. And since I have really got into it and really enjoyed it. So it's a good place to start. And it holds a little bit of sentimental value for me as well. But on top of that, it's super useful. I find that I use it really often. Well, not really often, but there are cases where I can use it in my personal life, and definitely at work, I've used it extensively. So I guess for those that don't know, is a statistical programming language used a lot in data science and data analytics. And yeah, I suppose it's often seen as an alternative to Python. So the two of those, people argue about which one they prefer, but those are the two big languages when it comes to data science. So that's what R is. Today, what we're going to be talking about is the Tidyverse, which in a sense is a package in R, but the way that R works means that Tidyverse is basically a language in of itself that's written on top of R. So it's kind of just this really simple way of manipulating data. And it's something that I think is really beautiful and intuitive and makes a lot of sense. So that's what we're going to have a look at today, and we'll get stuck in. So this lovely photo over here is of my now wife, Gila. And the reason that I've got a photo of us up there is because the hardest part about proposing was choosing a ring. So I went about it in the most romantic way that I know how, and that was with data analysis in R. So we're going to have a look today at a data set of different diamonds and see if we can work out how to get the best bang for my buck, if you like, which diamond I should choose to make that proposal. All right, so I mentioned we're talking about the Tidyverse. So why does it have this name? So it's built on this paradigm of tidy data. And what tidy data is essentially just tables of data, but the rules are that your variables are the columns, and each row represents an observation. So let's have a look at our diamond data set, and I'll show you what that means. So we can see that the columns here, each of them represent a different variable. So for example, the carats, the cut, the color, the clarity of the diamond, and each row represents an observation in the sense that each row represents one diamond, and each column is a characteristic of that diamond. So whenever we want to manipulate data, particularly using the Tidyverse, we want to have our data in this form. So sometimes when we get our data, it's not going to be in this form, and I'll show you a way later to transform it into this correct form. But if we have it in this shape, then it makes it really easy for us to use. So that's kind of the whole paradigm of what tidy data is all about. And we're going to spend some time looking at how the Tidyverse goes about manipulating data like this. All right, so as I mentioned, the Tidyverse is a package, the way that you would install it, but it's actually a collection of packages. So the one package that we're going to have a look at to start off with is called dplyr. And it's a very small vocabulary, which I really like. There's really these 5 key functions that we have to learn how to use, and then we can combine them in really interesting ways. And there's a really nice way to combine them, which I'll show you as well. And we can create these data pipelines where we start with our table and we just continue to make these transformations just using these functions. So the way that we write it is almost quite declarative in the sense that each of these are verbs. So we start with the table and then we're going to apply our function, or we're going to apply some kind of transformation to our table. So that's kind of the idea about dplyr.
Snoyman, sorry to interrupt. So Melina wants to know, is the diamond dataset available for the participants to use?
Yeah, great question. So once you call library tidyverse, actually I'll show you now. We'll move across, but the short answer is if you've got tidyverse installed, then the answer is yes. All right, so let's go to learn about the select function. So before we get started, hopefully you've got something like this. As I mentioned before, if you want to open up a new script at the top here, so this is what our RStudio looks like, which is a nice way for us to interact using R. So we can call functions directly in the console down the bottom. So for example, I want to bring in library and then tidyverse, like that. And we can see that when this finishes, it's brought in these 8 different packages. So the tidyverse consists of these 8 packages. And it's just a neat way to call them all in. So I'm actually just going to copy this up here. I could have called that from my script just inline using Command Enter. It could be Shift Enter. I can't remember if I've changed my settings, but you can write a script and then just call it line by line. So that's a really useful way to, I guess, explore our data. So that diamonds data set, fantastic. That came built in with the ggplot package, which I'll talk about later. So if you just type in diamonds into your script there, and if we go Command Enter again, oops, then you can see that we've got our data set that's built in there for us. So that's what we're going to have a play with today. So before I show you select, the first thing that I want to do is just rename the one column color. And the other reason that this is a good little exercise for me to show you is that it shows us how we can assign to variables in R. So I'm going to just overwrite the name diamonds. And then all of our functions, so this rename function here is also part of dplyr, as you can see. And all of these dplyr functions work in much the same way. So the first argument that we pass to it is the data set that we're dealing with. So in our case, diamonds. And then we want to rename our column color over here. So the way that we do that is we first write the name of the column that we would like to change it to, and then just go equals the old column over there. So if we run that command there, then you can see that our new diamonds data set, we've changed the name of the color. So the one thing that I'll just point out is that assignment in R is often done with this arrow operator. You can do it with an equal sign, but I guess it's idiomatic to do it with an arrow. So you'll see that a lot more frequently. There might be a couple differences, but in practice, I haven't really encountered any of them. All right, so when we're dealing with RStudio, a nice little shortcut, just so we can have a nice document that is readable, is Command-Shift-R, and that can give us a little section header. So we're going to have a look at select to start off with. So you can see this gives me a nice little break to play with. All right, so let's go back to the slides quickly. So as you can see the image over here, what select does is it takes a table. Just gonna put my jacket back on. It takes a table and it gives us a way to select certain columns from that table. So pretty straightforward. So let's see how we use this. So if we have a look at our table over here, our diamonds table, today we're only going to be interested in carrots, cut, color, clarity, and the price. We've got these other columns which are quite technical, just in the sense that as an everyday diamond buyer, they're not so relevant to us. So we're going to leave those behind. So the way that we can do that is we just call the function select. Again, the first argument is always the table that we're dealing with. And then we can just add the names of the columns to select them. So carrot, cut, color. Just in the chat here, how did we get the select header again? So on Mac, which I'm using is Command-Shift-R, which adds in a section, and then you can give it a name over there. I hope that helps. All right, so we can just continue adding in the column names that we'd like, separated by commas. And the last one that I wanted was price. So that's one way to go about it. Another way we could actually do it is to do the opposite. So deselect all the ones that we don't want. So if we have a look at what our table looks like, we don't want depth. So we just go depth minus table minus X minus Y minus Z. So that'll give us the same thing as what we had before. So two different ways to do the same thing. I'm going to show you a couple other ways that we can use select. If we don't want to select using having to write out every single column, there's a couple shortcuts that we can use. And depending on the table that we have, it could be useful. So one way we can use the colon operator, which is going to select columns from A to B. So we can go again, select diamonds, and then I want columns from caret all the way up to clarity. So I'm running code using Command Enter. It could be Shift Enter for you, but I can't remember if I've changed my defaults or not. But just if you've got your cursor in line, then if you just hit Command Enter, you should be able to run that line of code. All right, so the way, great, thanks, Victor. So yeah, as I was saying, to select columns, we can go from carets all the way to clarity. You can see carets all the way to clarity, and then we can add in the price as well. So that's another way that we can get the same thing. So yeah, as I said, I'm just showing you a bunch of ways that we can use select. Instead of using the column names, we can use the column numbers. So everything in R is indexed with 1 as opposed to 0. So we can go 1 to 4 and then add in the price as well. If we didn't want to write in price, we could go 1, 2, 3, 4, 5, 6, 7. And that'll give us the same thing as well. And then the last way that I'll show you that we can select columns is using a function. So we're dealing with the 4 C's of diamonds here, if you've ever heard of them, the carets, cut, color, and clarity. So it makes sense. It might be really readable to say we only want the columns that start with the letter C. So there's a nice little helper function that comes with this, diamonds, and then we just put the function in here, starts with the letter C, and then we also want our price column in there. So that's another way that we can select. So a whole bunch of different ways that we can use the select, and depending on the context, the different options are really useful. So the one thing which I'll show you is that if you just hit the question mark and then the name of any function that you've already pulled in, you can just go Command Enter. If you're having problems with Command Enter from the script, you can do the same thing in the console down here, and then just hit Enter, if that's helpful. So it's a little bit small, but once we enter that help command, it brings up the documentation on the right there. And this has got a whole bunch of different information as to how we can use the select function. So all these different things are explained, different options. And then it's also got some other things that we can do there. So that might be helpful. And we can use that if we get stuck with a different function as well. So that's select. The main thing which I'll point out is that our diamonds data set hasn't changed. So R is functional in that sense that we're not going to, in general, we're not going to have any side effects on the tables that we're dealing with. And that's going to be really useful later on. So the diamonds data set hasn't changed. It only changes when we reassign it. But each of these ways, we can see what happens if we were to apply that function like that. Okay, fantastic. So let's move on. So the next function that we're going to have a look at is mutate. So mutate we can actually use in 2 different ways. The first is we just take this column here. So if we use mutate on a column that already exists in our table, then we're going to mutate the values in that column. So we're going to do a transformation on those values. If we can also use mutate on a column that isn't in our table, and that's going to add a column to our table. And we can add that column based on our previous columns. So another little thing which I'm going to explain now. So all right, so let's add in our next section header, which is going to be mutate. So Command Shift R. hope you can see the commands in the top right. Hopefully that's helpful. If you're not on Mac, then maybe less so, but there's a constant reminder of those keys there. All right, so mutate. Again, none of this is necessary, but it's kind of just visually pleasing so that we can keep track of what's going on. All right, so let me show you how to use mutate in a second. The first thing that I'll show you is what a vector looks like in R. So we're just going to call our vector, we'll call it B. So the way that we create a vector is using this C function, which stands for concatenate. And then we can just put our numbers in here, for example. So you can see when we run that, nothing prints out in our console because we've assigned V. And on the right-hand side, you can see all of our local variables that we have over there. So if I just pop V in there, I can see 1, 2, 4. And again, if I highlight and then go Command Enter, I get the same thing. So these are kind of all useful little tricks, and you start to learn your way around. So the one thing about vectors in R is that they are vectorized, which means that if we apply a function to the vector, it applies that function to each item in the vector. So what do I mean by that? A very simple example. Let's go x plus 3, let's say. So this might seem like it doesn't really make sense if we're adding a vector to some number, but what that's going to actually help us do is just add 3 to each of our elements in our vector. Oh, sorry. Great, so you can see that we've added 3 to 1, 2, and 4. And then we can also multiply, and we get something like that as well. So that's what I mean when I say that R is vectorized. So the way that we can think about each of the columns in our table is that each of them are actually a vector. And the way that we can access them as a vector, so currently we're seeing it in this tibble format, which is part of the Tidyverse. It's this neat way of looking at a table. As you can see, we've got our columns and we've got our rows. Very seldomly will we actually work on the rows. We pretty much always think in terms of columns, and I think that simplifies things a lot. One of the reasons that I really like using this. But the one other thing which I'll point to quickly is that underneath each column, we've got this little piece of information there, and that's telling us the type of the column. So the first one there is a double, so just a floating point or a decimal number. So we can just put that in there, and then if we just use the dollar operator, then that you can see there, if we do that again, that's going to give us a choice of all the different columns that we've got in our table. And if I just pull that out, so this has turned it into a vector. So not particularly good to look at. I'll show you one more. So which column did I want to have a look at? Color is a better one. And I'll use distinct, which is another dplayer function that works on tables. Not such an important one for just now, but again, first argument is the table, and then we say we want distinct values of the color column. So if I was to do something like that, so this is going to tell me the different colors that I have in my table. If I want to extract that now as a vector, we use our dollar operator and pull out color. So I'll point quickly, we can see that our color is this ordered factor. That's what that type is over there. So it's basically just strings, or you can think of them as factors and strings, pretty much the same thing, but this has some kind of inherent ordering. So this might seem somewhat arbitrary. It looks like it's alphabetical, if you like, but this is actually, if we're thinking about diamonds, the best color diamond to have is referred to as D, and the worst color is J. So we could go and we could research that. Another way that we could have a look is we can actually have a look at this diamonds data set. This came with some documentation as well. And we've got some information on each of the rows, on each of the columns that we're dealing with. So here, if we have a look, D is from best to worst. So a little bit strange that they've chosen to go that D is less than E when D color is better than E. We're going to deal with that a little bit later. But that is, yeah, obviously the choice that they made. So we can get that kind of information from there. All right, so that's all pretty useful stuff. All right, so as I promised, we're going to have a look at mutate. So each of these columns, as we saw, we can extract them with that dollar operator. Each of those columns is just a vector. And if we apply mutate, what that allows us to do is to change that column just by using the column names, essentially, because of this vectorization. What that means is if we apply an operator to that column name, it's as if we've applied it to the entire column. So I'll show you what I mean. Yeah, it is currently being recorded, so that's fine. All right, so let's go mutate. Again, with all of these functions, I'm going to keep saying it. The first argument is the table that we're dealing with. And then let's say that we want to change our price. So we can see over here that the price is in US dollars. So let's say that we want to change it to Australian dollars. So I actually don't know what the exchange rate is. But all we have to do, so the new column name, so the same when we did that rename up the top, where our new column name comes first. So the new column is going to be price, and we're going to set that to price times 1.3. All right, so great. So we've seen, if we look at our previous table, so price was 326 for the first one, and then we multiplied it by 1.3, we get 424, and it's applied that across the entire table. So that's really useful. So that's what I mean by it's vectorized. We've got this vector price, which we're multiplying by 1.3, and that applies that to the entire column at once. So remember what I said about mutate, that if we're dealing with if this thing here is a column that's already in our table, then it's going to change the table, change that column. If we wanted to create a new column instead, we just have to choose a different name. So we can go diamonds, and then we might want to call this price in Australian dollars is equal to price times 1.3. And then you can see that we've added on a new column over there as opposed to changing the original one. So we can use this in two different ways. All right, could not find function mutate. So make sure that you've installed Tidyverse is the first thing, and then called library Tidyverse, which imports the package. That should fix it for you. For those that didn't see the question, there was just some error with mutate. Okay, fantastic. All right, I'll just show you a couple other examples of mutate. So diamonds. So a useful metric that we're going to be using is the price per carat. This, I guess, helps us to compare between diamonds of different sizes. So this we're going to call our price per carat, PPC, and that's literally going to be a price per carat. So I hope that in reading this, it's kind of really, everything that we're doing kind of makes a lot of sense. Like, it's very simple to apply these operations because they read the way that you want them to. And the last one I'll show you, so these are just simple operators for like times and divide. We can also use any function. So there's a function that comes with the Tidyverse. So there's a package in the Tidyverse called stringer, which is a whole bunch of functions that help us deal with strings. And one of them is string to lower. So I'm going to do color equals color, sorry, string to lower of color. So this function here, again, we can just have a quick look at what it does, but as you'd expect, it takes a uppercase letter and changes it to lowercase. And all we have to do is call it on our column name like that. So other functions other than the standard ones are also vectorized in that sense. So you can see that color now has changed all to lowercase. So that's mutate. All right, so what's next on our list is filter. All right, so this one is going to only keep the rows that correspond to the different conditions that we're going to give to it. But even, so as I said, we don't generally deal with rows. This is somewhat of an exception, but the way that we tell the table to do that is based on the column. So again, we're only talking in terms of the columns. We don't have to worry about the row numbers or the row names or anything like that. We're just going to deal with the columns. All right, so let's get stuck in. So, all right, let's create a nice little header. All right, so first one we're going to do is we're going to say, let's look at all the diamonds that are better than the color G. So again, first argument, diamonds, and we just do color. So I said is better than, but the way that they ordered it, remember when we had a look at this call up there, the way that the colors are ordered is in decreasing order. So we want anything from D G up till D. So put G as a string there. And yeah, that does exactly what we expect. All right, so that's just a single condition, if you like. So these are kind of all Boolean operators. If we want to combine them, there's a couple ways we can do it. We can just add extra conditions. Oops. And then let's say that we want our cut to be good. So again, so this is equivalent. So now we've filtered our data so that all of our entries have color is better than, at least as good as G, and the cut is good. So this comma there, we could actually replace with an and it would do the exact same thing. But for readability, that can sometimes be useful. So an and like that, that's going to do exactly the same thing. It's just looking at this as one condition as opposed to two separate conditions. Of course, we can do or as well. So this is going to keep, for example, our cut here is ideal, but our color was better than G. So that's why we've kept it just using the or operator like that. Another use of the or operator I'll show you quickly. And then there's one other thing which is useful, which I'll show you. So let's say we want color equals I or color equals J. So that would be one way to do it, just to filter based on that color. So again, remember, we're only dealing with the columns, we're only dealing with the colors and the cuts, for example, but we're keeping the rows. So we're only keeping the rows observations, we're only keeping the diamonds that are either color I or J. A nicer way that we can write this, we could obviously keep adding onto that, etc. Another way that we could write this is filter diamonds and then color in I, J. So we'll just unpack this quickly. It does exactly the same thing. So this over here, remember, was we were creating a vector. So we're just saying we're going to keep it if color is in that vector there. When I say vector, it's like a list. You could think of it that way as well. There is a list data structure in here, but a similar kind of thing. All right, and then the other interesting thing is these percentage signs that surround the in. This is kind of just syntax in R. It doesn't actually do anything, I don't think, but it indicates to us that this is an infix operator. So this is actually a function itself, but usually we put it inside of the two arguments. So equivalently, we can write this using our backticks operator, and this turns this into a prefix operator like we might be used to. So just a normal function. So if we call it like this, I believe this should work. So yeah, so these infix operators, if you haven't seen them before, something like a plus or a times, often we put those in between two numbers. So 3 plus 4, we could write it like that. Alternatively, in R, we can think of that plus sign as a function it does something like this, right? But the way that we turn that infix operator into a function like this is we just use those backticks. And then it does the same thing. So that could be kind of useful just to think about what those infix operators are. Just a little intro to some base R as opposed to tidyverse. All right, great. So that's done with filter. Let's keep pushing. All right, so the next one I'm going to show you is arrange. This one's quite simple. Only really used for, I suppose, like visual purposes, so that it looks nice. Maybe if you wanted to find something when you're playing around, you don't often need to use the function. So sorry, just quickly, arrange arranges the columns according to some order. So yeah, as I said, if you're doing other kind of manipulations on the data, oftentimes it doesn't really matter what order it's in. But it's just to help us kind of get a feel for what our data looks like. All right, so new little header. If I can spell that right. Okay, so let's sort our data set by cut. So arrange diamonds by cut. So that's going to sort them according to that cut order there. I think this thing keeps moving, but that's how you do add the new header. All right, so that you can see it's so our data set did look like this. Once we arrange it, it now gets it sorts by the column cut. If we want to sort by cut and then by color, we can just add another argument. So we're going to have this in there. And then if the cut is the same, then we want to determine ties by color, would be another way to think about it. So now it's ordered by cut and by color. And then if we want to sort in reverse order, diamonds, then we just use this descending function, and that's going to just sort it in the reverse order. All right, let's move on. That one's not particularly interesting or enlightening, but it can be used and is important. All right, so the last one is summarize. So this is quite an important one because this is how we derive insights from our data set. So summarize gives us often a summary statistic. So we can get this entire table and we want to say we want the mean across all of our diamonds. So the mean what? The mean, we can get carats, we can get, I suppose mean in this case would probably be, we could only use that for the numerics. We could get the most frequent of a different one, for example. So this is kind of useful. So let's have a look how we use our summarize. Okay, so let's go. Summarize. Sorry. Diamonds. So then, yeah, let's get the mean. So yeah, I can call this whatever I want. So we'll call it m carat, and this is going to be the mean. So that mean function is built into R. It does what you expect it to do. And then we want to do the mean carat. So that takes our diamonds, takes this table diamonds, and it just gives me back the mean of all of those, the mean carats of all of those diamonds. So hopefully that makes sense. And it returns to us another table, would be something to know. All right, so that in of itself is somewhat useful. I'll go back to the slides. So that's what we just done. The next one, which is very useful, is to combine a group by and then use a summarize. So this, we want to group by our table, group by a certain variable. So for example, we would use this in the instance that we wanted to find the mean number of carats, or the mean price given a color. So so I want to look at all of my diamonds that are color G, and I want to find the mean price for those. So something like this would be really useful. All right, so as I keep saying, so that group by, I'll show you what that looks like quickly. Hopefully some of you have seen this. It's fine if you haven't, but it's very similar to in SQL, how you'd use a group by. So let's say we want to group by color. So in of itself, this doesn't actually do anything. Doesn't change anything in our table, but it adds these groupings to our table. So it's useful when we use a summarize after it. But as I keep saying, that group by returns to us another table. So if we want to apply summarize to that table, this has to be the first argument to summarize, because this is our new table. So we're going to do something like summarize, now our grouped table, and then we can do our mean. So here, you can see now that it's grouped it by, so for each color, we find in the mean within each of those categories. So that's our output. That's where we want to get to. But you can see that the syntax is a little bit clunky. So one way that we could make that a little bit better, I've done it in my slides, is we could take that group by diamonds over here, save it as some variable, and then plug that into our summarize function so that we don't have this nested call. But that means that every time that we want to do some kind of transformation followed by another, we have to come up with a new name, a new variable name. It's a namespace, whatever we're running out of. We don't want to have to do that every time. So enter the pipe. This is a really awesome operator. So you can see those the percentage signs. So that tells us that it goes in between its two arguments. But essentially what this does is allows us to create these pipelines, these transformations that I was talking before. So this is what it would look like. So we want to convert this using the pipe. All right. So technically what it does is the pipe passes the previous point in the computation to the first variable of the next function. So before, when we wanted to group by, we had to put our diamond into that first variable. The pipe is just a way of doing that for us. So it means that we leave the first variable empty and we just continue as we were going. So now when we go group by, we just group by color. And so this here is exactly the same as what we've done over here. All we're doing is we're taking diamond and we're putting it into that first entry of the group by. All right. And then we just pipe this. So now it takes the result of this and pipes it into the next, into our summarize. So m caret equals mean caret. So if you haven't seen this before, I think it's super cool. This for me is one of the highlights of R, highlights of Tidyverse, because it just makes things super readable. Can you pipe more than one variable? It's a good question. I'm not sure. I've never really had to do it. I'd probably say no, just for simplicity. But for example, yeah, I'm not going to get into it. I honestly don't know the answer to that. But if all we've got to think about is the pipe passing that previous operator as the first variable of the next one, and then we can create these pipelines. Yeah. Yeah, absolutely. All of these functions are only giving us back one output, all the ones that we've used so far. So if we want to pass the result of one function into the next one, then it's helpful that it's only expecting one. All right, so this is our pipe. So essentially what we've done is taken our table and we've applied the series of transformations to the table. And we can do that with all of these functions that we've used up above as well. And we can combine them using the pipe. So just in the same way, instead of your group by, you could do diamond and then filter color equals, what have we got? G. And it's going to do what we expect. All right, fantastic. So the one thing which I will point to, just for those that are maybe more experienced or are a little bit bored, because we're about to get into our first exercise. But in the meantime, I'll just point out, sorry, actually I want to have a look at price quickly, because this is what was weird. All right, so if we have a look at this, remember that the best color for a diamond is D, and then followed by E, F, G, etc. But we can see that the price, for some reason, increases as the color gets worse. So we can see that really quickly, just looking at our data. So very quickly, we've taken our diamonds data set. We've summarized it in such a way that we can actually draw some insight out of it, just using those two commands. And we get this really odd kind of observation that the price increases as the color gets worse. So keep that at the back of your mind. We'll work on that a bit later. We'll see why that's the case. But yeah, have a think about it. Maybe come up with a hypothesis of your own as to why that would be the situation for this data set. All right. So here are your D5 verbs that you've just all learned. Fantastic. And I'm going to get you to use these things to complete this first exercise over here. So the reason that the task that we're going to do, there's 3 tasks that kind of lead up to this rapaport report. And this is a way of pricing diamonds. So I'll explain this briefly. You don't need it for the first exercise. We'll come back to it in the next one, but I'll explain to you kind of the rationale for what we're doing. So this report is released, whatever it is, weekly, monthly, I'm not sure. And diamond sellers use it as kind of a baseline for selling diamonds, for pricing diamonds. So if you get a diamond, here, let's just do an example quickly. So if you have a diamond that is 0.45 carats, and you choose which table you deal with based on the bracket. So we can see over here, this is talking about carats between 0.4 and 0.49. So we want to deal with this table over here. The color of our diamond is F, and the clarity is VVS1, which is a very, very small inclusion. As I said, I've proposed recently, so I know what all of these acronyms mean. So all we have to do is find the corresponding slot in our table, so 33, and that is so this 33 is price per carat. So that means if we want price per carat in hundreds of dollars. So that means that if we want to calculate the price of a diamond given these three characteristics, we just go to our table. We say, all right, so the diamond was 0.45 carats. For each carat, it's going to be $3,300. So for that diamond, that's going to be our price. So that's how we use that rapaport report. We'll come back to that in a second. And the one thing which I'll point out is that the rapaport report is really useful for us in this context for determining how much a diamond costs, but it's not tidy data, which means that a lot of the time, if we want to do, we can't generate the insights that we'd want to do. For example, if we have a look at this table here, it would be, actually, I'll show you an example later, but I just want to point out now that this is an example of a data set that's not tidy. Remember, tidy was that we have different variables in each column. Here, we've just got different levels of the variables in each column. So useful in this context, but when we're manipulating data with dplyr, we want to have tidy data. So I'll just point that out. All right, so let's take 5 minutes. Most of these exercises we have done together. So I'm happy to share the code that we've done. I can move up and down if you've got questions, but fire up your R if you haven't already. And essentially, I want you to apply these 4 transformations to the diamonds data set. Choose a new name for this data set and assign it to that. So each of these represent a transformation. Use the pipe operator to link them together into some kind of data flow, starting with diamonds, and then apply one transformation and then another one, and then assign this table to a new variable. So when you've done that, let me know. And if you've got any questions, then shout as well. So I'm going to leave that to you. I think what's probably easiest, everyone should have the slides. I've posted them in the chat. For any newcomers, I can post them again. And then I'm happy to just share this. And you can see some examples. Yes, sure, I'll send the slides one more time. So yeah, we've got task 1 over there. I'm going to stop touching it. Give that a go, and then at 2:53, we will continue. All right, I'm just going to duck to the bathroom as well. All right, I'm back if you've got any questions. Yeah, as I said, feel free to really ask anything. I might go have a quick look online for a couple of answers to some of those good questions that we had before. All right, can I get a bit of an indication how people are going? Is anyone done? Do you want a little bit more time? Otherwise, we can work through it together. Fantastic. All right, I think let's get stuck in. All right, I'll give Chelsea 2 more minutes. To answer the question from before, functions in R can't return multiple things. It's only each function in R only returns one thing. So unlike Python, where you can have multiple returns, R doesn't have that same functionality. And as a result, I think piping only deals with one thing. You can return lists of items or vectors of items, but you can't have multiple returns. All right, so I want to get stuck in because the other exercises will probably take a little bit more time. So let's give this a go. All right, so I'm going to go back to our slides. So the first thing I want to do is change the column, change the spelling of the color column. All right, we've already done that. You probably haven't. So mine will look a little bit different to yours, but we've already done that. So diamonds. And then we want to apply some kind of transformation to diamonds. So what's the first thing that we want to do? So we only want diamonds that are cut at least very good and caret greater than equal to 3. So maybe a bit of interaction. So what function do I use to do something like that out of the ones that we've done so far? One of these ones? Yeah, perfect. So if we're selecting rows based on criteria, that's exactly what filter does. Hopefully the idea is that these verbs do what they say they do. So they should be fairly easy to remember. All right, fantastic. So we want to filter so that the cut is at least very good. And, sorry, caret is greater than equal to 0.3. So you can do that with the and, or you can have these multiple things over there. Oops. Great. All right, so that's transformed the table somewhat. Then the next thing we want to do is add our PPC column in hundreds of dollars. So mutate. If we're adding a column, PPC equals price per caret, and then we want per $100 in hundreds of dollars. So that's going to do it for us. You can see that we've got our PPC column that's been added on there. And then finally, we just want to select, sorry. So keep PPC, price, and our 4 Cs. So again, remember there's a bunch of ways to do this, but we're just going to keep it nice and simple. Go caret, cut, color, clarity, price, PPC. Okay, fantastic. So that's task 1. Hopefully that was a good summary of what we've done so far. And we wanted to assign this to a new variable. So these are diamonds that are at least very well cut and they're somewhat big. So we're going to call them excellent diamonds. So once I do this, so yeah, I can highlight parts of this and run it, for example. So as I mentioned, this diamonds data set doesn't change. But once I create a new variable, then now this stores all those transformations for me. All right, fantastic. So I'm going to show you a couple more somewhat advanced things in dplyr, but they are quite useful. So the first thing is joins. So I'm not going to spend too much time talking about this. If you've got questions, happy to answer them. But essentially, this is a way of combining two tables. As I said, if you've done any SQL, this should be kind of second nature to you. And you can look at how these things all work. But it's a way of combining two tables on a common key. So that is something that I use all the time, particularly when you're dealing with relational databases. If you want to add metadata to a table, this is kind of really, really useful. So all of these joins all exist in dplyr. That's kind of all I want to say. And the next one, which is a tiny bit confusing, is this pivoting. So I suppose the clearest way that we'll see it is this is really helpful for moving from a data that is untidy to one that is tidy, or going the other way around. So for example, our rapaport report that we saw earlier was an example of an untidy data set by our definition of tidy. And if we want to make it tidy, we can use this pivot longer. And if we want to, if we want to create this rapaport report, which will be the next question, from a tidy data set, then we're going to use this pivot wider. So let me go into a couple of examples just to show you exactly how that works. So yeah, that's our rapaport report again. All right, so pivoting. Sorry guys, just getting my example up. All right, fabulous. So a data set that comes with dplyr, I think, one of the Tidyverse packages is relig income. So this is, it's somewhat analogous to our rapaport report that we had before, where, so remember, point again, rapaport report, we had colors. On the top, we had clarity. And then inside, we've got our price per carat. Think about that as our model, as our X, Y, and our values in there. So here we've got our religion. On the top, we've got an income bracket. And then this is kind of like a survey. So it's a tally of how many people per religion fell into that tax bracket. So for our definition, this isn't tidy. We don't have a different variable in each column, and each row doesn't represent a single observation. So we want to use pivot longer to make this data tidy. So what that means is we want to take these columns here, which is our income bracket, and we want to create a column out of that. As opposed to having them as the labels of our columns, we want to create a column with those headers. And this is going to help us to make it into tidy data. So that's why it's called pivot longer. So we've got this wide column where we've got all these different column names, and we're going to combine those into a single column to make it a longer table as opposed to a wider one. So again, we can use our pipe. Hopefully this is becoming more natural, this pipe operator. I kept emphasizing before that we have to put the table, the first argument is always the table. But now the first argument gets piped in, so we don't have to include it. So that's why it's super useful. And that's also why the convention exists for all the other functions, that the first argument has to be the table, because it allows for that piping. If a function doesn't have, if you want to pipe something into the second or third argument, you can do that, but it's not as natural. Yeah, so just ignore that. Piping in its vanilla form always pipes into the first argument. All right, so we want to pivot this longer. So pivot longer, fabulous. So we want to take all of the columns except for the religion column. So if you remember, so we can use the same syntax as we were using for select, which was minus religion. And then we want to take the names too. So names sub 2. So it's taking our column names to a column that we're going to call income. And then the values 2. So we're going to take each of these values in the square over here. We're going to take that to the count, or the tally if you want. So again, these are just column names. They can be anything. But there we go. So we can see now, in some sense, this is more tidy than what we had before. One of the reasons that it's really useful to have tidy data is we can answer all kinds of questions that we couldn't have answered before. For example, if we're having a look at this original table, if I wanted to know how many people were interviewed, very difficult to do, right? there's no, the functions that we've used so far wouldn't make that very easy to do. But once it's in tidy form, all we have to do is sum up this tally column. So any ideas how we could just sum that up? Maybe using a summary statistic. Someone will put in the chat which function we need to use. So we would use group by potentially first, but if I just wanted the total amount of people that were interviewed, so I don't really care about the income bracket, I don't care about what religion just yet, then I wouldn't necessarily need to use a group by. If I just want to get the total tally, so the total number of people counted, we can just jump straight to a summarize. And then we want our total equals sum. There's a nice sum function which sums up a vector. We put tally in there. So now we can see very quickly that we've got 35,000 people that were interviewed. If we wanted to see how many people were interviewed per religion, maybe that's an interesting question. That could, let's say that these are all random people that were interviewed. This would give us a good idea of the breakdown of religions in society. We could have a look at it that way. So then we would use our group by religion, and then our summarize. And then we can see how many people were interviewed per religion. So that's what the group by does. The group by just allows us to summarize within the groups. But if we just wanted to get a total, we can just summarize straight away. Great. If we wanted to get, let's do this quickly. If we wanted to work out the percentage of people, then we can just go, I forgot it actually, I haven't done this for a while. It'll come to me, I'll come back to that, but it's not so important for now. All right, so that's pivot longer. I want to now show you pivot wider, because we're going to use that. So we've got our data now, which is long. So there was an extra pipe there. It's waiting for another argument. That's what went on there. All right. So we've got our long table. Now we want to pivot wider. So now we want to have it back to the original format. We want to have it looking like this, because this is actually really useful. If we ask the question, all right, so if you're out of the Catholic people, how many people earn between 30,000 and 40,000? Then we can go straight to it. So this is really useful for us looking at. We could do the same thing with the longer table as well, but we can't see the whole longer table. It would take us a lot longer. So it's actually useful to have it in that wide form, even though for other contexts, we want it to be tidy. So if we have a table that looks like this in long form, in tidy form, and we want to go wider, then you can see that in a sense, they're inverses of each other. So we've got pivot wider. We don't have to worry about religion here, because all we're doing is we want names from, this time, from the income column. So now the new names of our columns are going to be all the different unique values of income. And then values from equals tally. So that takes us back to exactly the same form that we started with. So in that sense, these are kind of inverses of each other. If we apply one and then the other one, we get back to where we started. So that's pivot wider, and I'm going to give you a chance now to use pivot wider and pivot long, or just pivot wider, to create the rapaport report. So let's go do task 2. All right. So I'll give you some time to do this. The first thing that you need to do is we take the table that we finished off with in task 1. If you haven't done that, just let me know and I can paste some code in the chat. And you can continue on from there if that's helpful. So the first thing you need to do here is to create those categories. So for example, we want our table to look something like this. we want to have, instead of income, we want to have a range of carrots. And then instead of this tally, we want to have that PPC, the price per carrot. So those are going to be our values, and this is going to be our names. So remember that what we want to do is so we'll have to filter out just for one bracket to make it a bit easier. And then create this table here based on our data. So I'm running, you can do this in your own way if you've got an idea about how to go about it. But the task that I've given will step you through how to do that. So the first thing that we have to do is create a column which takes those brackets. So the reason that we do that is because caret is a kind of continuous variable. It can be anything from 1 up till 5, including decimals, etc. But we want to group it. We want to look at groups of carets. So for example, over here, we want to look at diamonds that are in this range. So this cut function allows you to do that pretty neatly. So just have a look at that question mark cut in the docs. So remember, if you just run that question mark cut command, it'll tell you how to use that cut function. And that's going to return back a vector. So what that means is you can use that along with mutate to create your new column, which is going to be your intervals. And then you want to find your median PPC, median price per caret within each interval, color, and clarity. So I don't think I showed you that, but you're going to have to group by multiple variables. So you just do that in the natural way, the same way as select, for example, and store this table in a new variable. Then you want to filter out for all of the diamonds within this bracket and use pivot wider to create your rapaport report. So quite a lot to do there. Give it a go. If you get stuck, we can work through them one at a time and then I'll let you go. But give that a go. What would be useful for you? Do you want to see the code? Do you want to see the, I think that's probably better. You can use this as your example. So check out the exercises on the slides. And yeah, we're going to continue on from this table here. So we've got these excellent diamonds that we did in task 1. And we want to first add on our interval. So for example, this one would fall in the interval between 0.3 and 0.4. So that we want to have a column that indicates that there. So that's what that cut function is going to do for you. So have a look if you can read through that documentation and work out how to use it. And in the slides, I've actually given you, oops, I've given you that breakdown there. So you can use that as an argument to your cut function so you don't have to write that yourself. So this just creates a vector with all those lower bounds so that the cut knows where to create those cuts. All right, so I don't understand what column we're trying to create. All right, so if we have a look back at our rapaport report, so it creates a different table for each kind of bracket of diamonds. So that column is going to just be a string that represents which bracket it falls into. So for each diamond, which bracket does it fall into? Does that make more sense? So it's just a column of strings, and really that cut function does all the hard work for you. Let me play around and see if we can just look at an easy example of how that works. Might be useful. What does this do? So I'm just running some things from the documentation, which might be helpful. All right, so here's an example if you're still stuck. So these are just the breaks that we've decided to use. So the ones that we are going to use is our caret lower bounds, which I've defined in the slide. So it's just a vector of different numbers. Then we can think of our caret column as a vector that looks like this. And that cut function just assigns each of those caret values to a bracket. So 0 fits, so our breaks are here. So 0 fits into the bracket between -3 and 0. 5 fits into the bracket between 3 and 5. So then that's going to correspond to something that looks like that. X here is this function, sorry, this vector over here. So in our case, that's going to be our caret column. Tx0. So Tx0 is just this random. All right, so to Chelsea's question, it says X must be numeric. So you've got to put it inside a mutate, make sure that you've piped in the previous table, and then your X should just be the caret column. So caret should be a numeric vector, so it shouldn't be a problem. X, yeah, I've just defined it on the, just basically from that documentation. So that Tx0 is just the number of times, it's just a vector. And then when we do the rep function there, it just repeats the numbers from 0 to 8 according to the number of times defined in the previous vector there. Anyway, I wouldn't get too bogged down in that. All right, let's do question 1 together. I was hoping that the documentation would be a bit easy, but under time pressure like this, it's a bit difficult. So let's have a look how we'd go about it. All right, so we need to get our caret lower bounds in there. So this is just a vector that we're going to define. So if we call that in there, then that's just a vector like what we were dealing with before. Oops. Great. Okay, so now we got excellent diamonds. Okay, we want to pipe this into a mutate because we want to add this column on. So we're going to call this our size interval. So remember, here's what our table looks like. and we want to add a column now called size interval, which tells us which interval the caret fits into. So we're going to use the cut function that allows us to do that. So the first value is caret, so that's going to give us these variables. Then we want to give it the breaks, which is how to define those intervals. So that is these caret lower bounds. So if we were just to do something like that, that would give us that column like that. So where did, maybe because if one of you want to post your code just to see where you got up to, if you don't mind, or if you want to explain where you got a bit stuck. I suppose this cut function, it also works on individual values. So instead of worrying about a whole vector, so we've got these lower bounds. If I just say 0.45, like in our example in the slides, it's going to give me back where it fits in to these bounds. And the fact that it's vectorized, it's going to do that for every row once we put it into the mutate. That's the idea. So there's a couple more arguments which we can add here just to make it a bit prettier. So we want to include the lower side. So set that to true. So that means that we want a closed bracket. Are they different? They are slightly different, but the only difference is that we've already filtered out all of these excellent diamonds. Remember, we filtered for carets that were greater than 0.3, so none of them are actually going to fall into there. So I can get rid of that. That's fine. That's going to give us the same thing. So this include lowest, that's just going to give us a closed interval if we do that. So you can see now we've got it's including the lower bound there. And then the right, again, there's no real reason that I'm doing this, but I'm just making a decision that this is how I want to do it. So then that right false means that I don't want to include the upper interval. So that's just reading the documentation of cut, include lowest and right. So we go in the opposite of what they usually do. That's, yeah, as I said, that's how, I guess that was just a good example of how you can read the documentation to try work it out. But that is tricky for a new language. All right. So now we've got our size interval. So I hope that's more clear now what we were trying to achieve. So the next question is we want to find the median price per caret within each size interval, color, and clarity. So this is important because we want to find this value. So for each size interval, we want to find the median for each within each color and each clarity. And that's how we can generate this table. So we kind of want to replicate this from a data standpoint. So this is done by experts who know exactly, like, if this is how much I would spend on a diamond with these characteristics. But we're just looking at the data. We're saying we've got this raw data. We've got a whole bunch of diamonds that are certain color, certain clarity, and we've got the price. We can generate this based on the data of our previous observations. All right, so that's task 2. So sorry, that's the second part of task 2. So maybe you want to now group by. So group by 3 variables, and then summarize. So why don't you give that a go? All right, any success with the group by and summarize? So did you change the column color, the spelling? And are you piping into your group by? That's strange. So after you do this excellent diamonds and then I mutate with cut, sorry. So just back to Chelsea for a second. So if this is what you're looking like after that command, then everything should be in order. I'll show you how it looks like. And then when we do the group by, we just call them as different arguments to the group by function. So the same way that we would do a select, for example. So group by, size interval, color, and cut. Oh, sorry, clarity. Haha, thought it was the pipe. Yeah, you get used to it. It's all good. I'm about to confuse you with something else, so don't worry. All right, so there's our group by. So Milen, I hope that answers your question as to how group by looks like. And then we just want to summarize median. So call it M, PPC, maybe mid, PPC. Well, let's go PPC, why not? Equals median, PPC. Okay, great. So this is what it is supposed to look like. So then the last thing that we have to do, we'll call this one rapaport report. So now we've got this. And the one thing which I will add, so you saw by the end of this, we've still got this grouping on our table. It shouldn't be a problem, but we don't want that grouping anymore. So the way that the summarize works, if you group by multiple variables, by default, summarize will just remove the last layer of the group. So if you're only grouping by one thing, then it takes away all the groups. But if we're grouping by 3 different things, then it kind of just peels off the layers each time you summarize. So we can fix that by adding an extra argument to summarize, which is actually a new in dplyr. They've just come out with a new update, which allows you to do this. And then this is going to drop all the groups. Hopefully. Why didn't that happen? Oh, groups, apologies. There you go. So now we don't have that grouping information anymore. So if you're doing some analysis, that can come in, that could be annoying. If you're trying to find the mean across everything, but you've still got those groups in place, then it's not going to allow you to do that, for example. All right, so then the last step is to do the pivot wider. All right, I'm going to just put this in here and then see if you can do the pivot wider in just one more line. So pivot wider. So give it a go. Yeah, don't worry too much about this for now. Just because we're running out of time, I'd rather go through some other stuff, but just so you get a practice with pivot wider, this is what our table now looks like. So now we're only looking at that interval there. So the diamonds are only between 1 carat and 1.5 carats. We've got rid of that column. We've sorted by clarity. And now we've got our 3 columns and we want to use our pivot wider. So remember, we've got names from, and values from. So see if you can just fill that in and get our rapaport report. I'll give you a minute to have a look at that. All right, so what's names from? So we want our, if we look back at our rapaport report, we want the names to be clarity. So all we have to do is names from our clarity column. And the values are going to be our PPC. And then the color is going to remain on the left-hand side. So we've got a rapaport report. So now we've created exactly what we saw over here. So that's great. That is the end of task 2. All right, let's kick on. So another really important part about data analysis is plotting, is visualization. And ggplot, I think, is a fantastic way to do that. So we'll run through it quickly. So when I said that you keep forgetting the pipe, now you're going to hate me. ggplot, I suppose the difference here is when we're dealing with dplyr. So again, ggplot is a package that came with the Tidyverse. So Tidyverse is a collection of packages. One of them is dplyr, which is for tables. ggplot is for plotting. So dplyr works on these verbs. So the reason that we use the pipe is it's this transformation. It's often instead of saying the word pipe, when you read the code, you might say then. So for example, diamonds, then group by, then summarize, then mutate, then. So it makes sense because they're kind of all verbs. When we're dealing with ggplot, we now have a plus. And we can think of this plus as adding layers as opposed to doing transformations. We're adding layers to our graph. And each of these things are in some sense nouns as opposed to verbs. So this first line, when we call out ggplot, this sets up our basic plot. We'll do a bunch of examples, so you'll see how this all works. So again, first argument is data. Sorry, I will jump back to the pivot wider. So you can see that there, all good. And then we're going to go back to plotting. Right. Sorry, I'm just conscious that I want to get through some of this plotting stuff because I think it's super useful. And then, yeah, if we're just going to run out of time today, but I'll give you all the slides, all the codes, and please reach out to me whenever if you've got any questions. All right, so this, again, first argument is our data, which means that we can apply all of our transformations and then pipe the final table into ggplot. Fantastic. So data is our first argument. And then the next thing that we get is this mapping. So all this is, we have to wrap it in this aesthetics function. And it's what goes on the X axis, what goes on the Y axis, and then we can choose to color different categories. So I'll show you how that works. Then on top of that, we choose what kind of graph we want. So that's we add these different geoms to our ggplot, different geometry. So we could have a column plot, a bar chart, a histogram, a scatter plot, which is geom point. And then theme we can add on to make things look pretty, and labels as well. So this is kind of the result of what ggplot can get for us. So I'll show you how to do this one. It's a little bit complex, probably a bit too much, but there's no end to how much you can kind of customize these and play around with them. So let's go back to the code and have a look. This is task 3. All right. So ggplot. All right, so I want to answer that question that we had from before. One interesting little hack which you might like is that when we're done with a section, we can just collapse it like that, which is another nice reason of doing things this way. All right, so I want to use this as our starting point for ggplot today. So did we have any hypotheses? Did anyone have a chance to think amongst all of the the new things that we're learning, why the price would be increasing as the color gets worse. If you didn't have a chance to think about it, just say no and we'll move on. And we can work it out together. All right, that's fine. Yeah. So that's definitely it. That for some reason the diamonds are bigger. So I guess why is that the case? We can still have a think about that. Would be the next question. But yeah, I think that's the main thing. Is that for some reason the distribution of the diamonds is kind of slanted towards J. My hypothesis would be that there aren't very many J diamonds that are going to be in our data set, because no one's going to buy a diamond that's got color J unless it's really big. And if it's really big, then that's going to influence the price more so than the color. That would kind of be my guess. So let's have a look at different ways of visualizing that and seeing if we can kind of maybe confirm that to some degree so we can feel confident with that. So the first thing that we're going to do is we're going to take this table and just kind of maybe we only saw that trend before because I had pointed it out. But if we visualize it, it becomes really clear. So again, here's our table. Lovely. We're going to pipe this table as the first argument to ggplot. And then what ggplot needs is this aesthetic function. So this is, remember, it just needs our x variable, what goes on our x-axis, what goes on our y-axis. So that's the bare minimum. Sometimes, depending on the geometry that you're going to use, you don't even need an x and a y. You might only need one. For example, a bar chart, you just give it the x and then it counts the number of y's, or it works out some statistic for you. So you don't have to give it both an x and a y. But here we're going to have a look at a column plot, which is just going to give us the color on the x coordinate and the price as our y. So we've got to remember to do a plus as opposed to a pipe, and I'm very sorry. And the people that created ggplot and Tidyverse are also very sorry about this. It's one of their biggest regrets that there's this clash, that these two things are so similar but actually are different things. But for ggplot we use pluses because we're adding on layers. That's how we can think about it. And then all we have to do is add on garm col, which is a column graph, and it should pop up over here. Lovely. So pretty easy. We just specify our x, specify our y, and what type of graph we want, and we get this beautiful looking graph straight away. So all of this is just a table. So that's just the first argument. We've worked that out already. That part's easy. Well, if it's not easy, we've done it in the past, so that's fine. We've got it in this form. So we've got this table here, and we want to graphically represent that. All we have to do is give it the x value, the y value, and the geometry, which in our case, we want to make it a column graph. All right. So again, now we can see very clearly this weird kind of trend that we spotted earlier. So one good thing to do in these kind of scenarios, maybe I can, I'll name this table so we don't have to keep doing the operation every time, make it a little bit faster for ourselves. So this is going to be, what are we looking at? Price per color, PPC again. We'll just call it price color. So we'll get rid of that. And then we can just pipe price color into here instead, because we're going to use that over again. Okay, perfect. So if we get some kind of weird result, often it's good to look at a box plot or at the quantile. So we want to look at kind of the distribution. So how confident can we be in the numbers that we're getting? So all we have to do, similar thing. And then just instead of col, we can just go box plots, I think. Yeah, box plot. So that's an attempted box plot, but I don't know why it's done that. Sorry guys, I don't know why it's drawing it like that by default. Anyway, I'm going to leave that one. I'll come back to it just because I want to push on. We're looking differently at the price. Anyway, apologies. All right, so now we're going to look at the price, but we also want to have a look at the mean mean carrots. Oh, sorry, I know why I did that. It's because in order to do the box plot, we need to have all the data. It needs all the data, not just a single value. So me saving this didn't really help. We just want to pipe diamonds into there. And price is not there, but price is there. There we go, that's a bit better. So we can still see that to some degree we have that trend, but these lines are kind of a good indication that if they overlap, then we're not confident in our outcome. So that's kind of a good rule of thumb. If these error bars are overlapping, then we can't really be confident that it's telling us much. Basically what that means is that we don't have enough information to be confident of this. Okay. So again, we can be skeptical. All right, so Chelsea suggested before that the diamonds might be bigger in those categories. So let's have a quick look at that. So price, again, mean price. Carat is going to be mean carat. And we can see that that hypothesis looked right. That as the diamonds go, the color gets worse, the mean size of the diamond increases. So the diamonds get bigger as we go, even though and that's why the price is increasing. So that seems to make sense. All right, what did I want to have a look at? All right, so if carat is what's having an impact on our diamonds, why don't we limit the carat to a certain range and then have a look at our plot? So we'll take our first one that we were dealing with. Pipe that in. So let's first filter so that our carat is greater than 0.9 and carat is less than 1.1, and then look at our mean and then plot. So just doing exactly what we did before, but this time looking at just carats within a certain bound as opposed to all of them. And now we can see the trend that we're expecting. Again, we probably can't be too confident of that. We probably don't have a lot of observations in J, but that seems to make more sense. If we looked at price per carat, that might also negate that because it takes that carat information into account, and we're looking at the price per carat as opposed to the price of the entire diamond. All right, so another way that we can see this is using fill, which is what I wanted to show you. So if we have a look at our diamonds data set, filter carats less than 2.5. All right, so now we're going to do a histogram here, which kind of is like a distribution. So ggplot, aesthetic. All right, so our X value, again, we're going to deal with carat. Sorry, this is different to what we've been doing before, but that's okay. So we've now got this continuous value carat. We're going to use the fill, which is another one which we haven't used yet for aesthetic, to add some color to our plot. And the fill is going to be the color column. So a little bit confusing because we've got color that's popping up in our table and also as an argument here. But if we just worry about, so we want to fill in our graph based on the color. So it's going to separate out each of these columns into their colors, into a distinct color, and we'll add a legend. So you'll see what I mean there. And then we want to just add geom histogram. So because we've got this continuous data, we've got carats along the x-axis. We want to group those carats into 5 groups, kind of equal size. So we give 5 there, and we can play around with it until we feel confident that that's what we want it to look like. This, in a sense, is doing very similar to what that cut function did back in task 2, where it did that grouping, but here it kind of does it for us. So instead of looking at individual diamonds that are carats that could be at any value between 1 and 5, or sorry, between 0 and 2.5. Here we're grouping them in groups. So quite pretty. We can get a lot of information just by using fill. So it basically adds another dimension to our plot, which is really useful. I suppose what I want to point to here is that if we look at where most of the color E diamonds are, for instance, there's a good chunk of them that's over here and very few big ones. So it means that in terms of contributing to the price, the diamonds that are kind of this size over here, which is kind of between 0 and 1, there's a lot of those E colored diamonds. That's what's going to contribute the most towards the mean, as opposed to anything that's too big and is going to lift off the price. So again, we can see that the carat is going to have the biggest impact on the price, as opposed to the color. Each of the color clarity has some impact, but the carat seems to be the biggest motivating factor. So that's how we can use fill. I'm going to add this in here just so you can see it, but really you can, as I said, you can customize these things to your heart's content. So this is exactly the same as what we've done up till here. This, if we add, so color when we're dealing with stuff like this tends to refer to the outline of the thing that we're dealing with. So this is just, again, just purely aesthetic, just adding a nice little border to each of these shapes over here. Theme black and white just gives us a different type of look. You'll see what that looks like. And then the labs is useful. This lets us rename the graph, put a little header at the top there. The X we can change to carats with the capital. Y we can do the number of diamonds as opposed to this count variable which they've chosen. And then fill. So remember, is this legend over here. So this is just giving new names. This makes makes the size bigger. You can do all these extra customizations. Cool. So there we go. So now that's like a really professional looking graph. And we didn't have to do too much in order to get there. So that's nice. You can obviously choose your own color palettes and stuff like that as well. Okay, lovely. There's a couple more things. I'll show you this one. There's only one, so that's good. I'll just show you this one and then we can move on to the last exercise quickly. Maybe we'll do it together because it's a bit of a tricky one. All right. So diamonds. So here, what I want to do is a scatter plot. So if we had a look at diamonds, we can see that there's 53,000 diamonds. So I don't want to do a dot for every single diamond in my graph. So that's why this sample just picks a random 5,000 and it gives us a good kind of feel for the total data set without being too intensive on the plotting graphic over there. Again, the X value is going to be carats, Y value is going to be price. And then we'll just do a scatter plot. So that's kind of, each dot now represents a single diamond. And that's what kind of it looks like as the carats get bigger. The one interesting thing which I point out here, and which I certainly noticed when I was buying a diamond, was that once you get to those kind of round values, so you can see at 1 carat, there seems to be a lot more diamonds there. And the price also tends to jump at that value. And again, at 1.5 and at 2. So we can see that on these round values, those diamonds, for whatever reason, like, I don't know, apparently girls like saying I have a 1 carat diamond as opposed to a 0.9 carat diamond. So that's why we can see that there's a lot of diamonds that are at that price point, and also that there's this this jump in price. So that was just the one thing which I wanted to point out there, and just another example of how to use ggplot with a scatter plot. Okay, so let's do task 3. So this we can do with ggplot. This is basically just a graphical representation of our rapaport report. So the price going from most expensive to least expensive, color, clarity. So why don't we just do this one together? Let's give it a go. All right, so I'm just going to do it again on on diamonds between 1 and 1.5 carats. So we've got our table, hopefully, rapaport report. What does that one look like? All right, so the interesting thing here is that even though this is kind of a graphical representation of our rapaport report, which looks like this as a reminder, we said that this data is not tidy. So the way that ggplot works, it also works with tidy data. So even though this is literally exactly what our plot is going to look like, we still need to use, we're still better off using data in tidy form to get something that looks like this. So our rapaport report we can see is in the tidy form that we want, so we don't have to convert to the expanded form. We want it exactly as it is like that. All right, so let's filter again. Oops. For carat in this bound here, 1 to 1.5. What didn't it like? It's because I've called this size interval. Okay, we've lost some of our diamonds. Let's find out why. So yeah, for some reason, so I can just have a look at distinct size interval. I need to give it the rapaport report. Oh, there should be some there. Okay, let's try again. Huh, what's going on? I'm not sure what I did differently there. Oh, I think there was a space. That's all it was. All right, lovely. So now we've got in this form, fantastic. So I think we are almost good to go in terms of getting ready to plot. Yeah, we are. Okay. We can do. Let's iterate here. All right, ggplot. So X, if we're having a look at what we want, X is going to be clarity. Y is going to be color. Sorry, this has to all be inside that aesthetic block, unfortunately, as well. And then we're going to start adding some layers. So, and the last thing that we want is our fill to be PPC. And then all we want is geom tile. So hopefully that gives us something. Okay, great. So this is kind of like a first iteration. Ah, thanks, Milena, you picked that up before me. So this gives us kind of a first iteration of that graph. We can see it looks pretty similar to what we want. The only thing that's different is we've got a different name on the axis there. Clarity is up the top. We can change that around. The color is obviously different, and the color and the clarity are going in the opposite direction. So we can fix all those things up. It's not too difficult, but I'm not going to spend too much time on that, I don't think. I'll just copy that in rather, and you can have a look at that later. So I've reordered them over here. The scale X discrete, that puts the label up at the top. The labels I've changed, and the gradients, I've just given it some colors for it to pick. So not too bad. Just really some customization there, which you have to Google every time that you do it. The last thing that I'll show you before we kind of finish off is that this is a good way to do it for a single graph. So here we were just looking at this size interval here. There's a nice little way that we can get a whole bunch of graphs on one page, and something like that might be useful here. So we use this facet wrap command. This here, for now, I'm just going to say that's how facet wrap works, but it's also a way that you can do anonymous functions in R. So notice the only difference that we've got here is that we haven't filtered for the size interval. And then we pop that facet wrap at the end. This will take a couple seconds just because there's a lot of data for it to process. And it gives us this nice little report over there. If we make that a little bit bigger, we can see that. So that's essentially this rapaport report for each different caret interval. And we can see that. So it gives us for each of those different intervals, we've got a new table, which is similar to that rapaport report. Is that what you want to see, Milena? Just that picture there? Oh. So the code, really the only difference is that one line over there. We just add that in and we say, we want to do each of the graphs according to the size interval, and then that creates the different boxes according to side interval. So that's really the only difference, which is pretty neat. Wonderful. All right. So that was a bit of an intro to ggplot. Task 4, which I think is always really important. We're not going to chat about it now because it's not specifically R, but whenever we're doing some kind of analysis, we want to see, are we actually answering the questions? I think that this is something important that I've learned in the work that I've done, is that I can go away and I can do all my, give you all the tables in different forms that you want. And, oh, I think my headphones might have died, but that's all right. I can give you all the analysis that you want. Give me a sec. Are we connected? Hear me? Yeah, perfect. So you can go away, you can do all the analysis that you want, you can come back with all these plots, but you want to answer the original question. So which diamond should I be buying? We can have a think about that as well. These ones I'll point out because they are really great. So Shiny is a way of using all the code that we've learned about today and very simply creating a website type dashboard for others to interact with. So I'll actually show you an example of one that I've made in the past. So that is super useful. You don't have to know any HTML, nothing other than what I've just taught you today, and you can create these really good looking apps for people to use, and I've done that in the past, and those are super cool. You actually do this using a flavor of Markdown called R Markdown. So pretty much you're just writing these text documents intertwined with a bit of R. There's nice support for that in RStudio. And out the other end comes a little applet. So that's really cool, something to look at. Something else that's super useful is dbplyr. So this is a database dplyr. What this allows you to do is, instead of having to save all of your, so for example, what we were doing now, we just had our diamonds data set that was as part of the package. That was nice. But oftentimes you want to read in a CSV of data. So instead of having to store, let's say you're working with a database, you don't want to have to read in that entire database into, yes, the graphs come out in Markdown, in the Markdown for sure. So let's say that you're dealing with a database. Instead of having to read in the entire table into your R workspace and save that kind of locally as code, that can be quite heavy to do, you can access your database with dplyr syntax. So for example, I learned dplyr before I learned SQL. So it was really easy for me to just hook into my database, run all my dplyr commands, and then only once I've done the summary, do the summary on the database end, so I don't have to bring that all locally, then bring in that smaller data set and then do my graphing and stuff like that. So I'm actually using dplyr syntax to query a SQL database. And if I use the show query command, it will translate this dplyr code into SQL code, which is really helpful when I was learning some SQL. So that's a really cool tool. This is a really awesome resource. So this Hadley Wickham, he was the guy that created the Tidyverse. He's really awesome. And this book basically goes through everything that we've spoken about today, plus much more, and really, really nicely. I still use it as a really good resource to remember things, to learn new concepts, to expand on some of the stuff that we've done. So that definitely check that out. That's really, really awesome. So yeah, welcome to do any questions. In the meantime, I'm going to get up. I'll get up an example of a Shiny dashboard that I've put together. Let's see if there's a simple one. I don't want to put the code up at the moment because it doesn't belong to me anymore. I was working with one of my lecturers, and then it now belongs to him. So I'm not going to show you the code, I don't think, but I'll show you what it looks like as a finished product, which is pretty cool. But yeah, you can find lots of different examples of how to do this. Yeah, as I said, I just did this using R Markdown, which was super simple. I can send you an example after we stop recording, for example. All right, so this is a dashboard that I created. You can see we've got these nice little tabs over here. We can see what's going on. We can do these tables. We can download these data sets so that we can input them. I might actually do that because I don't know where I've saved that. So we're going to download a data set, which we can then import over here. This is probably taking Shiny dashboards to the extreme. You'll see what I mean in a second. I don't think it was necessarily built to do these kind of things. But they're really cool. So basically we've got these criminal networks, and we're visualizing them as graphs. And you can kind of click on there, and we've got all this different information. So basically we start out with a table that looks like this. We've got the different connections and weather and different attributes. So we feed both of those pieces of information in, and it generates this graph over here. Then the question was, all right, so these all represent criminals. This is our kind of kingpin over here. We can see that that's determined by these graph features. And then if we want to arrest this guy, so we'll go arrest, and then we see what happens to our new graph. So that was kind of useful. And as I said, super simple. I've got no idea how to do any kind of HTML stuff. And this was just using R, which I was able to create that. So that's super useful. You can do a lot simpler things that just have like a dashboard. Something that I did at a company that I worked with was create a dashboard of kind of key metrics that they put up in the office, and we could update that daily based on our database, and then we could visualize that, put up a TV screen on the wall, and have a dashboard like this that was kind of inspiring everyone with the key metrics. So super powerful stuff. All right, so yeah, any questions? Thank you so much for joining me. I hope that was informative and useful. After this, I'll share a GitHub link with all of the code that we worked on today, all the slides, etc. Reach out to me on Facebook or LinkedIn or anything. If you've got any questions, I'm always happy to have a chat and help you out.
Thanks so much, Snoyman. Yeah, I hope everyone enjoyed that. It's nice of Ryan to sort of give us 2 hours of his time. And yeah, we'll put the recording on our Facebook page. And yeah, just thanks again, Ryan. That was awesome.
No worries. Thanks, Shane. Appreciate it.